Now we come to the concept of adaptive modulation and coding in the LTE. Now we know that a user equipment is assigned resources by the E node B in the form of resource blocks, and some of these resource blocks are used by the user equipment for the uplink communication of data to the E node B, and some are used by the E node B for the downlink communication towards the user equipment. And in one such resource block there are 12 subcarriers. Now the next question is that what is the modulation scheme that is used on these subcarriers in a resource block. There can be there can be three types of modulation schemes: QPSK, 16 QAM and 64 QAM that can be used. Now suppose this user equipment is away from the E node B, then most likely the channel conditions between the user equipment and the E node B are bad, and user equipment is getting feedback about the channel conditions from the E node B. So in bad channel conditions, the QPSK modulation scheme performs better and it produces less errors. So the user equipment would use the QPSK modulation, and in the QPSK modulation there are 4 samples and there are 2 bits per sample. So here the user equipment would be sending 2 bits per sample. Now if the user equipment is very near to the base station, then it is most likely that its channel conditions are very good, and in that case this user equipment would use the 64 QAM modulation scheme, where the user equipment is sending 6 bits per sample. And whether the user equipment is here or whether the user equipment is here, in both the cases the sample rate is fixed. The only thing that is changing, it is the bits per sample. Here bits per sample is less and here bits per sample is more. So here there is higher data rate as compared to when the user equipment is here, and when the user equipment is in some intermediate place, then it will use the 16 QAM modulation scheme. So the data is varied as a function of the channel conditions, and we try to take benefit of good channel conditions by using a higher modulation scheme that is sending more data in the same frequency bandwidth or in the same number of resource blocks. And so this is known as the adaptive modulation, where we change the modulation as a function of the channel conditions to change the data rate. Then the second thing is adaptive coding. Now forward error correction codes are used in the LTE for the error correction at the receiver. And how it is done? It is done by adding some extra bits to the communication from the user equipment to the E node B, and these extra bits are used at the receiver to correct the errors. Now if the user equipment is away from the E node B, in that case we will use a strong forward error correction code. That means we are going to add more bits for error correction, so there will be less space for the actual data. But when a user equipment is near to the E node B, we will use a weak forward error correction code. That means we will add less number of bits for the purpose of error correction in the communication of the user equipment. So here obviously when the user equipment is near the E node B, more data would be sent to the E node B. So by adopting the modulation and the coding, actually we adopt the data rate as a function of the channel conditions. So and the adaptive modulation and coding not only takes place in the uplink, but it also takes place in the downlink.